If you are a beginner in React or already have some experience with it, it doesn't really matter. This video is for everyone who have time to watch it and learn the fundamentals of React. Let's start without an intro. Starting with JSX, which stands for JavaScript XML. JSX is a syntax extension for JavaScript that allows us to write HTML-like code in our JavaScript files. It helps us create and structure our React components in a more readable and intuitive way. When we compile our React application, the JSX is transformed into simple JavaScript, which then can be understood by browsers. We use JSX for readability, scalability, and support for inline JavaScript. Here is a simple React code which uses inline JavaScript. Here we have initialized two variables and we are using them inside our JSX. Next up, we have components in React. Components are the building blocks of a React application. They are reusable and encapsulate both the UI and the logic. They can be anything from inputs, buttons, headings, or even strings. Think of them as Lego blocks for creating interactive UIs. Every component in React must return at least one element or null. And in order to return multiple elements, the component must wrap them inside a parent element. But using a div as parent will result in an extra element in the DOM tree. And to solve this problem, we can use something called fragments, either with react.fragment or much better with an empty tag. Props or properties. Just like we have attributes in HTML, which helps us set data to elements, we have similar concept in React called props. They are read-only data passed from parent element to child elements. Let's say you have a component for displaying welcome message. You could do something like this. But here, the title and the message is hard-coded and we have no way to update it. But with the help of props, we can make it dynamic. Since React puts props in the first argument of any component, we can make this component accept title and message by getting values from the first argument. Another way is to directly destructure the values instead of creating new variables. And then later we can pass values to the welcome component and the component will render whatever was passed to it. One more thing about props is that it is not just limited to strings or numbers. We can also pass objects, booleans, and even a whole component. Let's discuss hooks in React. Hooks are functions that allows you to use state and other React features in functional components. They provide a way to hook into React state and lifecycle methods of a component, and they usually contain names starting with use. Some commonly used hooks include useState for managing component state, useEffect for handling side effects, useRefs for manipulating DOM elements. Here is an example of using useState hook. Refs provide a way to access and interact with DOM elements directly. It is similar to document.getElementById, but React provides its own way to read or modify an element's properties. Most common use of refs are focusing input box or controlling media playbacks. To create a ref, we use useRef and then point its variable to the element we want. Then on click, we can use ref.current.focus to focus that element. Context provides a way to pass data through the component tree without having to pass props manually at every level. Without using context, if we had to pass specific data to numerous elements, we would proceed incrementally, which results in prop drilling, where props are passed through multiple levels of components. Context, however, provides a centralized way of keeping data, and then it can be accessed from any component without passing props, which makes the code cleaner and more scalable. To create a context, we first have to use react.createContext. This function lets us create a special kind of component that can pass data directly to other components. Then we use its provider and wrap relevant components where we want to access the data by passing the value of the data. This value could be of any type, including state value. Then we can access that data from any nested component using useContextHook by passing the context variable. So, what exactly is state in React? Well, think of it as a data storage system that each component in React can have. It is like a memory where components can remember things. Imagine you have a React component. This component can have its own internal data called state. This data can be anything: numbers, text, objects, you name it. Let's break it down with an example of a simple counter application. In this code, we have a counter component. We define a count state using the useState hook starting at 0. The useState hook returns an array of two elements. The first element is the current state value, and the second element is a function that allows us to update the state. Next, we will use the counter value to display using h1 tag and add two buttons, and on click we will call setCounter function with the older value plus 1 As the user clicks on the button to increase the counter value, the count state updates and React re-renders only the necessary part of the UI. One thing to note about state is that its value is only limited to that specific component. You cannot change or read value of the state from another component. You can pass them down using props, which could end up in prop stealing. But we have two ways of fixing this problem, either with context or using a global state manager like Redux, MobX, or Zestant. Okay. Before we talk use UseEffect, let us first understand how React renders a component. React uses a virtual DOM to efficiently update and render components. Instead of directly manipulating the actual DOM every time there is a change, React compares the virtual DOM with the real DOM and only updates what's necessary, leading to better performance. To take an example that React only updates what was changed instead of updating the whole component, let's have a look at this code. Here we have two counters in a single component and two buttons to update them separately. When we inspect the element and click on the first button, we can see that only the first h1 is being updated. This means that React is only updating what was changed inside a component. Now, let's talk about UseEffect. Imagine you wanted to make an HTTP call to a server. How would you do it? Well, in React, these are called effects and provides a way to manage them. We use UseEffect hook to work on something that's not React, like making HTTP calls, creating subscriptions, handling WebSockets, etc. Let's create a simple app to fetch user data from a fake endpoint. We will also add pagination to better understand UseEffect. First, we will create a state to store user data and another state to store current page. And inside the UseEffect, we will call the endpoint with the page number and store the response in the user state. Then we will display the user's name and email using conditional rendering and add a button for next page. And on click of the button, we will just increase the page number. As of now, nothing will be reflected since we haven't provided any dependency to the UseEffect hook. Let's add page as a dependency. And now when we click next, the API will be called and the next data will be fetched from the API updating the user state. And it happened because React is calling the effect function every time there is a change in its dependency. Here it's page. Portals provides a way to render children components into a different part of the DOM hierarchy. This is useful for scenarios like models, tooltips, or any UI elements that needs to break out of its parent's style or positioning constraints, while still being logically related to that parent. To use portals, we can use a portal with React DOM.createPortal, passing the child and the container. As you can see, the p tag is rendered outside the root element. Components in React do not support async handling by default. You cannot use await inside a component, but React provides a way to use them using something called Suspense. Suspense is a feature that allows component to suspend the rendering while waiting for some asynchronous data to load, such as data fetching from an API or code splitting with lazy loading. Suspense helps improve user experience by showing fallback content like loading spinners while the requested data is being fetched. Once the data is ready, React updates the UI with the actual content. Let's have a look at an example to better understand Suspense in React. First, we will create an async function to fetch user data from an endpoint using Fetch API. Then we will create another function called createResource, which will serve as a bridge between asynchronous data fetching and the React Suspense feature. Suspense is designed to suspend rendering while waiting for some asynchronous operation to complete, but it requires a way to trigger this suspension. Simply put, Suspense needs to know when to wait for something and when to continue rendering. It relies on the throwing of promises to indicate that a component is not ready to render because it's waiting on asynchronous data. Next, we will create a user data component which will call the read method from user resource data. And inside the app, we will render user data component inside React Suspense component with a loading indicator passed in the fallback props. Lastly, let's discuss error boundaries in React. Error boundaries are special React components that catch JavaScript errors anywhere in their child components tree and log those errors, preventing the entire application from crashing. By using error boundaries, you can isolate errors to specific parts of your UI and provide graceful error handling, such as displaying a fallback UI or prompting the user to reload the page. To create an error boundary, we will have to use class component because as of now there is no way of creating error boundaries using functional component. We will create a class called error boundaries extending React component with a state to check if an error has occurred and a method called componentDidCatch. This method is called by React if there is an error in any child component, and inside the render method we'll just check for error before rendering the child component. And inside the app we will wrap our component where we want to handle the error. And just for demonstration, I have added a button. When clicked, the component will return an error. Thanks for watching. And in the next video, I will cover up the fundamentals of Next.js. So make sure you have subscribed to the channel with notification turned on to get notified. And let me know if you liked the video in the comment section. And thanks for watching. Peace.